Today we are going to be talking about histograms. So we've been talking about numerical data, and we've been focusing for the last quite a few days on box plots and how box plots represent numerical data. Today we are going to talk about a different way to represent numerical data, and that's histograms. Histograms organize numerical data in bins based on the class interval that they fit into. So whether we want to group it by 5s, 10s, 20, 25, etc. And the bars are connected. So histograms are different than the bar graphs that we talked about. They're very similar, but they are different. So you remember that bar graphs are separated and they are for categorical data. Histograms are connected and they are for numerical data. On the horizontal axis, this is going to be your class interval. And on the vertical axis is going to be the frequency or relative frequency. Cannot spell today. And this is the same as when we did a bar graph. So remember, on that y-axis, you can either do the count, which is the frequency, or you can do the relative frequency, which is the probability. It does not matter. All right, so the following is a set of data describing the number of cousins each student has. So if you look at this first chart, all of those numbers. So someone has 10 cousins, someone has 15 cousins, someone has 33 cousins, someone only has 4 cousins, someone only has 1 cousin. So this is saying how many cousins someone has. What we want to do is we want to create these intervals or these bins for our data. So to create the histogram, we're going to choose those intervals. So the first interval is between 0 and 4 cousins. Now we want them to be equally spaced. We try to avoid doubling the number. So I wouldn't say 0 to 5 and then 5 to 10, because where does the 5 go? Does it go in this one or this one? So we don't overlap those numbers. So our first interval is between 0 and 4. And there are 5 numbers there: 0, 1, 2, 3, and 4. 5 different. So we're having groups of 5. So our next class is going to be from 5 to 9 cousins, 10 to 14, 15 to 19, 20 to 24, 25 to 29, and 30 to 34. Now what we've got to do is the frequency. How many times did that occur? So I look for 0 to 4. Anywhere that I see 0 to 4, I'm going to include 4. So if I look through, there are 5 different people that have between 0 to 4 cousins. We go for 5 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so I want you to go ahead and press pause now and continue to count and fill in the remainder of the class intervals. Sometimes this is where we struggle because you get a wrong answer because you counted wrong. So just make sure that you're including all of them or cross them out as you use them, and that way you know you've accounted for all of them. All right, so if you counted correctly, there would have been 11 students that had 10 to 14 cousins, 6 for the next one. There are no students that had between 25 and 29, but there were 6 students had between 30 and 34 cousins. All right, so let's go ahead and take this information and create our histogram. When you're creating any kind of chart, whether it's a pie chart or a bar graph or a box plot, which we didn't focus on this one as much, but you want to give it a title so that whoever is looking at it knows exactly what's going on. So this histogram is going to be talking about how many cousins we have. On the bottom is going to be our intervals. So our first interval, I'm going to label this 0 to 5, 10, 15, 20, 25, 30, 35. And we see over here that we know exactly what's involved in each of those, so we don't have to worry about where is that 5 going to go. We have that data in our table. And the highest number that we have is 13. So let's go by 2s because it'll be easier. So let's go up to 14, 2, 4, 6, 8, 10, 12, 14. Okay, so in the first one we had 5. So it's really similar to your bar chart, but again, it's not a category, it's a range. And notice how each of these are equal amount. It wouldn't make sense to have one bar that represented 10 different numbers and one that did 5. Because if you did that, you'd be purposely skewing the data. Each of these are representing 5 numbers. So they have to be representing the same amount. The frequency is going to change, but we have to be fair here. And that's representing 5, 13. Remember, the main difference between that bar graph and the histogram is that the histograms bars are connected to each other and the bar charts are separated. The histogram down here, this is going to be our interval. And on this case, we did frequency or count. So the y-axis on the histogram and the bar graph is the same, but they are going to be connected. Our next class we have here is 11. Between 15 and 19, we only have 6. 20 to 25, only 1 person. No one between 25 and 30 there. 30 to 34, we have 6. Now, if you don't like how I labeled 0 to 5, because technically 5 is going to be in this one, which is fine, you can always say this is 0 to 4, this is 5 to 9, and so forth, if that makes you feel more comfortable. Okay, so we have talked about how to create our histogram. Now let's answer some questions based on our histogram. What is the least common interval? Well, that one is really easy. So the least common is going to be between 25 and 29 cousins. But then, if we look at here, no one has more than 33 cousins. Remember, we created the histogram and we created those class intervals. Maybe you did groups of 10 versus groups of 5. We wrote this one down in 5 because 5 was very manageable. We didn't have too many bars. But if it had gone up to 60, 70 cousins, all of a sudden we have way too many bars. So you're going to create class intervals that make sense for your set of data. What is the most common? We can see right up here. The most common is between 5 and 9 cousins. And I think you guys get it. The lowest bar is the least common, the highest bar is the most common. What percent, so we're changing things up here a little bit, what percent of students have between 10 to 14? If we are talking about percent, we want success over total. So how many students have successfully 10 to 14 cousins? There are 11 out of total. So total, we have to add up 5 plus 13 plus 11 plus 6 plus 1 plus 0 plus 6, and we get that there are a total of 42 students that were questioned, 11 of them having between 10 to 14, so 11 of the 42. That would give me the probability. I'm going to change that into a percent. So 26.2% of the students have between 10 and 14 cousins. What is the median of the data set? All right, so this is going to bring us back to when we talked about the mean, median, mode, and this is a frequency table. We've talked about this before. We're going to talk about it again in our notes tomorrow, but a frequency table is a little bit different. You can do this in your calculator or you can do it by hand. It doesn't matter. But remember what median means. Median is going to be the middle number. So if I'm looking here and there are 42 students, I cut that in half. I'm looking for the 21st data point. That's going to be the middle. But the key is, remember, it has to be in order from lowest to highest, which is what our histogram does, and our table as well. So if I'm looking at this, here is my fifth. Remember, I'm looking for my 21st. So 5 to 13, that's 18 people, plus another 11, that's going to give us 29. So our 21st data point is going to happen in that third row between 10 to 14. I could have also looked at that on the histogram. 5 plus 13, that puts us at 18, 29. So it's going to happen within this class interval. So according to the histogram, that's going to happen between the 10 to 14 cousin interval. Now, if you were only given the histogram, that would be as specific as you could possibly get. But this isn't always going to happen. If we look here, we have all of the data. So if I were to go back to the original data, which most of the time you don't have, you just have the histogram. If you calculate the median of all the data, the median is actually at 10. But again, so you can look at it from two different directions. If you look at it from the histogram, you're looking for the 21st data point, which is going to happen within that interval of 10 to 14. All right, let's turn it over to the backside. Good news on the backside, we don't have to create any histograms. All we have to do is be able to read them. Most of the time, you are going to be given graphs, and you have to be able to interpret the information and answer questions based on it. This is what a lot of the ACT stuff is. How many people were in the sample? Oops. So we have no information except for what was given in our chart. So we see different age groups, how many people in those age groups of their favorite M&M candy. All right, so these are different ages that say M&Ms are their favorite candy. How many people were in the sample? Well, if there's 3 here, 27, 46, 54, 38, 26, I take all of those and I add them up, and there are 194 people. What was the most popular age group that had M&Ms as their favorite candy? Clearly, we just go to the most popular, the tallest one. There is 54 people in that group, and that is between the ages of 16 and 20 years old. What is the median age group? So we don't have all the data set like we did last time, but we do know there's 194 people. The median is the middle number, so we cut that in half. So we're looking for the 97th data point. So we have 3 plus 27 is 30, plus 46 is going to give us 76, and we want the 97th. So if we know that the 97th one is going to happen in here. So 76 plus 54, that's going to be more than 97. So that is also going to happen between the 60, oops, wrong spot, between the 60 and 20-year-old spot. What percent of people like M&Ms as their favorite candy who are younger than 11? So we've got a little bit more to consider here. It's anyone younger than 11. So we have 27 people from this group and 3 people from that group. Both of those categories are younger than 11. So we have to consider the 27 from 6 to 10 and the 3 from 0 to 5. Remember, that's success over the total of 194. 30 over 194 is going to give us about 0.155, which is 15.5%. What percent of people like M&Ms as their favorite candy who are older than 20? All right, so we go back to our histogram, older than 20. So we are looking at 38 and 26. Both of these groups are representing people that are older than 20. So we've got 38 and 26 fitting our description out of the 194 total. When we divide, we get about 0.3 to add an extra number in there, giving us 32.99%. Last question. Histograms and box plots can both be used to represent numerical data. We talked about that in the very beginning of our notes. So can we turn this graph into a box plot? The answer is no. A histogram cannot be turned into a box plot. In order to make a box plot, we would need the individual data points. But we could not see those in a histogram. So we don't know the specifics. So we know that between the age of 0 and 5, there was 3 of them. They could have all been 5. I could have had one 1-year-old, one 4-year-old, one 5-year-old. We don't know the specific data points, and without those specific data points, we wouldn't be able to create that box plot. Now on the front page, we would be able to because we had the data that we turned into the histogram. And then a big difference, a big important difference between these two graphs that show numerical data, box plots show outliers. Histograms do not. So that is one benefit of the box plot that the histogram doesn't show, is that those show those skewed data points that are pulling our numbers off in weird directions. All right, and that is it for today.